If you're a student in college, you may think that you have a pretty good grasp on how to understand figures and graphs and tables of all sorts. And then you take your first practice MCAT, and you see figures like this, or like this, or even like this. Seriously? Join me, a 100 percentile MCAT score, as I go through how I interpreted all the figures and tables and graphs on my real MCAT. So firstly, let's look at a passage that has a lot of different graphs and figures and tables in it. We can read it and then I'll show you how to interpret the figures. So in this first paragraph, we've been told a lot of things that honestly you should come into the MCAT knowing about neurons, axons, dendrites, all those good things. And you may also be holding on to your drawers because you realize it's going to be a physics passage. We're talking about the electrochemistry of a neuron. But then we get to table 1. The first thing I do when I reach a table or a figure is read any titles and figure captions that are associated with it. Table 1 says the electrical properties of axons. Obviously, here we're talking about neuronal axons. I also noticed that there's not a figure caption for this table, so I'm going to go straight into reading the titles of the columns on the table. We see on the left-hand side we have some sort of properties of axons. In the middle we have a non-myelinated axon, and then on the right we have a myelinated axon. So obviously we're comparing myelination versus non-myelination. Then I would skim through the properties. Okay, we have axon radius, resistance per unit length of fluid both inside and outside the axon, conductivity per unit length, capacitance and thickness of the myelin or the membrane. So I've picked up on a few basic sciences already, right? Resistance, conductivity, capacitance. Those are all things that we should know a little bit about before entering the MCAT. So I'm going to make a mental note of those. But really, there's so much on this table. I would pretty much do just that. I would just skim the properties. I might take a glance at the units of the non-myelinated and the myelinated axons. I noticed that there's ohms and there's meters, and I think that's farads. But I would spend absolutely no time actually comparing any of the properties of a myelinated versus an unmyelinated axon. Why? Because I have no evidence to say that they're going to ask a question about this. Yes, I see basic sciences in this figure interpretation. I'm making a mental note. If they ask me a question on table 1, they're likely going to prompt me to go back to table 1, or I'm going to have that mental note to say, okay, I need to know something about the capacitance of non-myelinated versus myelinated axons, so I'm going to go back to table 1. But in that case, I'm looking at titles, I'm looking at basic sciences and things like those properties on the left-hand side, maybe some units, but there's not a lot to look at in this table. Next, we see a figure, and it looks to me like it's some sort of circuit. And I read the figure caption, says a segment of a simplified electric circuit model of the axon. In looking at this figure, I'll be completely honest, I'm not the greatest at circuits. I'm not the greatest at electrophysics stuff. So I'm noticing that there are resistors in parallel and resistors in series. That's a basic science I know a little bit about. I know some equations that go with those, but I'm going to spend 5 seconds tops on this figure because I don't know that they're going to ask a question about it. Again, it's kind of the same as table 1. I would probably spend about 15 seconds on table 1 looking at all those titles, making sure that I know what the table is comparing and what the basic sciences within the table are. But I would only spend about 5 seconds on figure 1 because there's not much to it. It's just some resistors, and if they ask me a question on it, then I will cross that bridge when I get there. Moving on, let's keep reading the passage. So now we're on figure 2, and we see a huge basic science here, action potentials. You guys should have been expecting this when we had something on the electrochemistry of neurons, when we had a passage on that. So let's look at it here. First things first, I'm going to read the figure caption. It says figure 2, a typical nerve impulse, also known as the action potential. That gave me basically no new information, but a lot of times figure captions will have new information in it. Sometimes I've seen questions even asked specifically on figure captions, so make sure to always read them. So what do I look at next when I come to a figure like this? I'm going to look at axes. So I see on the, I guess you could say the y-axis of this, you see potential in millivolts. That's pretty typical of an action potential, right? On the x-axis, I see time in milliseconds. After that, I notice a little bit about how the potential changes over time. It's pretty typical of an action potential, so I make that note. But overall, what am I looking at here? Figure captions, axes, units. Now we can wrap up the passage. So in true MCAT style, they give us the science behind some sort of physiological process, and then they mention later on in the passage how that physiological process can be messed up or can be tested, and that brings in even more basic sciences that they can test us on. So that's the end of the passage, but what are the main takeaways for how to interpret figures on the MCAT? First things first, always read your titles and your figure captions. They will put answers in there. And you always want to know what you're dealing with to start with. Next, read axes. There was only one graph or figure that really had axes in this passage, but it's still important to know that I'm measuring potential versus time. And it's always going to be important to know your axes on your figures. The last thing that I would say that you guys really need to pay attention to is units. You noticed in that last figure that potential was in millivolts and time was in milliseconds. But they could ask me a question about volts per milliseconds or millivolts per seconds, and I would need to recognize that the values I'm pulling from the graph are not in the correct units, and I'm going to need to convert them some way or another. As a general rule, I would not want to spend more than 15 seconds on any specific figure in a passage. You just don't know that they're going to ask a question on it. To illustrate this, I'm going to show you all the questions that are associated with this passage. Comment below which figures that you think that they're pulling information from. Alright guys, that was your quick video on how to interpret figures on the MCAT. Comment below some of the most outrageous figures that you've ever seen on the MCAT, or any strategies that you want John or I to cover in future videos. Until next time.